welcome to another A-Level Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on computer architectures. To understand modern computer architectures, we should first start by looking at the history of general-purpose computers. Charles Babbage's design for the analytical engine, although only ever in theory and not built, was the first design of a general-purpose computer. A general-purpose computer is one that can be programmed to complete a variety of tasks, as opposed to some of the specific computing machines that were available that completed one specific task. Ada Lovelace is credited as the first programmer, as she wrote an algorithm using punch cards that could be executed on the analytical engine that was designed by Babbage. The ENIAC, or Electronic Numerical Integrator and Computer to give it its full name, built in 1945, was the first programmable electronic, general-purpose digital computer. It was built to calculate artillery firing tables for the US Army. To reprogram ENIAC required changing huge amounts of plugboard wiring that you can see here on the left, and setting the 1,200 switches found on each of the 3 function tables you can see on the right. This meant it might take weeks to map a problem onto ENIAC, and days in order to do the physical setup of changing the plugs and setting the switches. It was the mathematician John von Neumann who had the idea for the stored program concept. This is the idea that a program can be electronically stored in binary number format in a memory device so that instructions could be modified by the computer as determined by intermediate computational results. Some key features of the von Neumann architecture that he proposed include that it had a single memory store that holds both the data and instructions together in the same place. It would also have a single central processor with an arithmetic logic unit and registers for storing temporary values, as well as a control unit that includes an instruction register and a program counter. This processor would also execute instructions sequentially. It would also have input and output mechanisms, allowing for external mass storage. There are 2 main architectures used by most modern computing devices. Most general-purpose computers, like laptops and desktops, will be in the von Neumann architecture. The other architecture we need to know about is the Harvard architecture. Some key features of the Harvard architecture include having separate storage for data and instructions, which means they can be fetched simultaneously on separate buses. This makes the Harvard architecture very fast, but also more complex to build. Instructions on the Harvard architecture may be held in ROM, whereas data would require RAM for read-write access. The address bus and data bus can be different sizes to suit different needs. The Harvard architecture is commonly used in embedded systems, in particular those that use digital signal processing. Digital signal processing usually involves responding in real time to a number of sensors. The speed of the Harvard architecture makes it ideal for a range of uses, for example, flight control systems and navigation systems. That brings us to the end of this video on computer architectures. Join me in the next video when I'll be looking at the role of registers in the processor. Use the resources at MrGoff.com to help you revise computer science, and until next time, it's bye for now.